Okay, so yesterday we did introduce the linear models. Today we're moving on to the quadratic models. So remember I told you that when we're doing regression line, we're going to look at three different things: linear, quadratic, and exponential. So quadratic models represents quantities that are not linear. So they're nonlinear, which do not have a constant rate of change. So remember with linear, we had a constant rate of change, right? So the slope is constant all the way. With quadratic, you won't have that constant slope, right? Because remember that quadratic shape would be like this, where you have a decreasing slope, then you have an increasing slope. When you're looking at a table of value, which difference is equal, is constant for a quadratic function? The second difference. So you're not only going to stop at the first, you're going to have to continue and do the second difference, and then if that's constant, then you know it's a quadratic function or quadratic model. You don't understand what I'm saying? You'll see it in the next.
Now I understand what you said. I didn't understand when you first said it, but then when I pictured it in my head.
Okay. And then we're gonna see it in the table in the exam. Okay. What do we call the shape of the graph? A parabola. So the graph is a curve called a parabola. And the equation has a degree of 2 and is written in the form, so we're going to write it in standard form: y equals ax squared plus bx plus c, where a cannot equal to 0. Because the minute that a is 0, you're going to lose that term, and then you're going to end up with a linear function. You're going to lose if a is 0, 0 times x squared, that's 0. So you're going to lose the x squared term, and you're going to end up with something that looks like a linear function, bx plus c. Okay? So that's where they specify that a cannot equal to 0. Okay, so we looked at the three different things: the table, the graph, and the equation. The table, second difference will be constant if it's quadratic. The graph will have a parabola shape, and for the equation, it's going to have a degree of 2. Are we okay with this? So let's look at the example. Which model represents quadratic relations? Since I'm given a table of values, what do I have to do to figure out if it's quadratic or not? The difference. That's right. So I'm going to start with the first difference. So 238 minus 250.
Minus 12.
202 minus 238.
Minus 36.
And then 142 minus 208.
Minus 40.
Minus 60.
Huh?
Minus 60.
Yeah,
Minus
sorry.
So what can you tell me about the first difference? Is it constant?
No.
No.
No, so it is not linear, right?
Right.
So I have to move on to see if the second difference is constant, and if it is, I know it's quadratic. Okay? So we're going to do the second difference. And to do the second difference, you're going to subtract your first difference. So you're going to do negative 36 minus negative 12, which is negative 24. It will be negative because negative 36 is greater than plus 12. Okay? So if you do negative 36 minus negative 12, right? So it's negative 36 plus 12. 36 is a bigger number, so it's going to end up being negative. And then negative 60, take away negative 36, that's also negative 24. What happens is because you have a negative and a negative, it makes it a positive, right? So So what can you tell me about the second difference?
Constant.
Therefore,
Quadratic.
second difference is constant. Therefore, it's a quadratic relation. I gotta do the same thing for the other table to figure out if it's quadratic or not. So the first thing I have to do is the first difference. So 48 take away 32, that's gonna be 16. 78 take away 48, that's gonna be 24. And 108 take away 72, that is 36. So looking at this, I can say that it is not linear.
You got it constant.
Sorry?
It's not constant.
Because it's not. Now I have to check if it's quadratic, because the question is asking me which one is quadratic. So I have to do the second difference. So 24 take away 16, that is 8. And then 36 take away 24, that is 12. So, is it quadratic?
No.
Okay. So second difference is not constant. Therefore, it is not quadratic. Are you guys okay with this? All right. Now looking at the graphs, what can you tell me about the first one?
Parabola.
It's a parabola, that means it's quadratic, right? So graph is a parabola, therefore it's a quadratic. Do we all know how a parabola looks like? No? So a parabola is like a bell curve shape that's gonna have either a max or it can have a min, so it can look like this. Or it's gonna be symmetrical, right? So if I cut it in half, it's gonna be symmetrical, right? But it can be open up or open down. And that's the shape of quadratics. So any quadratic function to the power of 2, it's gonna have a shape of a parabola, either opening up or opening down. Okay? So graph is a parabola. Therefore, it's quadratic. What can you tell me about the second graph? So it's the height versus time.
Linear.
It's linear, it's not quadratic. So the graph is a straight line. It's not quadratic. So far we looked at a table, and we did first and second difference, and then we looked at graphs, and then if it's a parabola or if it's not. Now we're gonna look at equations. So looking at the first equation, what can you tell me? Is it quadratic or not?
Quadratic.
Quadratic because, how do you know that?
Square. Second.
So you see the degree on the x is 2, so it's quadratic. degree 2. How about the second equation?
No.
Not quadratic,
Okay.
Linear.
it's a linear function. That's one. Are we good with that? Easy stuff, right? This should be the easy stuff. Remember that when we look at formulas, sometimes we don't only have two unknowns. Sometimes we have multiple unknowns, right? So if you go back and remember the geometry formulas where we had like the volume is length times width times height. So I have 3 unknowns, 4 unknowns: volume, length, width, and height, right? Or when I looked at the volume of what is this? This should be, I think this is a cylinder. So that's volume equals pi r squared h, right? So you have the height is unknown, the radius is unknown, and the volume is unknown. But most of the time, my formula should only have 2 unknowns in order for me to be able to solve easily, okay? So what I do sometimes is I set one of my unknowns to a number, okay? So I make one of them constant. So let's say if I want to know the volume of the cylinder, if the height is 15. So I set the height to a number, right? So my only 2 unknowns right now are the volume and the radius, right? Because I set the height to a certain number, okay? Or I can set the radius to a certain number. Okay, and I can change the height. Do you guys understand what I'm saying here? Okay, so let's look at this. So we can make the equation quadratic, or we can make it linear, depending on what we set to a certain number. So let's write this. So, for example, in the formula for the volume of a cylinder, volume equals pi r squared h. The volume is your dependent, right? So the volume is the one that's replacing the y, so that's your dependent. While, what are my independent variables? R and h. While the radius and the height are the independent variables. So in this case, I have 2 independent variables, okay? But if I do actually try to solve this is going to be very hard to solve. So what I have to do is I have to set one of them to a constant number. So I want to say that I want to make my cylinders this height, okay? The radius is still unknown, okay? Or I say I want to make my cylinder this radius. I want it to be that big of a circle, okay? But then the height would be different, okay? So to determine the relationship between the dependent variable and one of the independent variable, you set the other independent variable to some constant value. You rearrange the equation to solve for the dependent variable. And you can determine if the relation is linear, quadratic, or some other. We'll do an example so you guys understand this way. Or some other nonlinear relation. Let's look at an example so we understand this now. So I have the formula D equals 1/2 AT squared, given the distance traveled by a car as it accelerates from a stop position where D is the distance traveled in meters, A is the acceleration in meter per second squared, and T is the time elapsed in seconds. So looking at this, which one is your dependent variable? D. D is my dependent. This is where it's by itself, right? What does it depend on? What letters does it depend on?
A and T.
A and T. So it depends. The distance depends on the acceleration and time. Are we okay with this? Do we understand that part? Good. So if I want to investigate the relationship between distance and acceleration, where time is equal to 2. So what does it tell me to do here?
Replace T.
Replace T with what?
2.
With 2. And then what would I have left in my equation?
A.
A and D. Right? So they want you to investigate the relation between D and A, where T is 2. So they want you to replace T with the number 2. Okay? So in my equation, which is D equals 1/2 A times T squared, we're gonna replace T with 2. And then that will be D equals to 1/2 times A times 4. Can I simplify this? 1/2 times A times 4, what is that equal to? What's 1/2 times 4? 2A. So you see, they gave me a value of T. I replaced it. Then now my only has 2 letters. Only has the letter D and the letter A. Make sense? Because usually in my equations I have Y and X. Right? In this case I have D and A. Can you tell me if this is a linear or a quadratic?
Linear.
Linear.
And how do you know it's a linear?
We got one.
And this is what the question is asking. Investigate the relationship. So what kind of relationship is it between D and A? Is it linear, quadratic, or neither? It's linear and it's the degree. Forgot the letter R. Okay. So, are you guys okay with this? So look at the second question. Investigate the relationship between T and D when A is 2. So what do?
Place A with 2.
Replace A with 2. And then when you do that, what do you have left?
By half. Half times 2.
Right? So I replaced A. You know what? I'm gonna write the equation first. So a half times 2 is what?
1.
So what kind of relation do I have here?
Quadratic.
Quadratic degree 2. So now you understand what the blob that I blobbed earlier on in that page? Okay. So now we're gonna go to Excel, but before we go to Excel, let's just fill out the. So as we did with linear regression, we're gonna do the same thing, but we're gonna do it with quadratic regression, okay? So we can use quadratic regression to model data that appeared to lie along a parabolic curve. I seriously don't know how your pencils last.
Get some of these.
To model data that appear to lie along a parabolic curve and produce a curve of best fit. It's going to be similar to the line of best fit, but it's going to be a curvy, a parabolic shape. Okay? So, a fountain sparks from a Canaday rocket follows an arc in the air. This table shows the height of the spark at various horizontal distance from the launching point. Use a graphing technology to determine the equation of the parabola of best fit. So it's telling you specifically to do the parabola of best fit, right? So parabola means quadratic. So we're gonna take these numbers, we're gonna go to Excel, and then we're gonna put them in Excel, okay? As usual, this one right here, that's gonna be your X, and this one, the height is going to be your Y value, okay? So let's do.
Is it always given like that? The table line, the X usually is given first. Once we see a table like this, the first points
Yeah.
are always X.
Unless it's like written in column form, then the first column would be X.
Okay.
So we're gonna enter the values of X.
do you have my password for the computer by any chance? No?
I have to log in order for me to be able to get it. I wrote it on a piece of paper for you, didn't I? Did you lose
I
it?
memorized it, but for some reason I must have hit something wrong.
Oh my gosh.
Maybe you're not logging in under the right thing.
Oh no. Okay, don't show me what to do. Try that. I got caps on.
Is he under AD?
Try to log into the website.
Website?
Thanks.
Okay, so do you have the Excel? Do you know how to open Excel, Mitchell?
Yeah, just help me. We got it. It's just opening up.
Perfect. Okay, so I'll enter the values in Excel as we did. Now what do I have to do?
Insert,
Highlight them
scatter.
and then insert, scatter, and the first one, right?
You did it already.
Did you get this? All right, so that looks good. What did we say we have to do? What else did we have to enter?
Trend line.
The trend line and the, I guess, the axis.
Okay, so to find the axis or to include the axis, you press on the plus sign. And then you have to tick off the axis title, which is the second one. Remember that? Now, what would I put on the my y-axis title?
Height.
Height, and then you have to include the unit, and then we usually include the unit in brackets. So height, bracket, meter, close bracket. And what do I include on the x-axis? What do I say?
Distance.
Distance, again, the same thing. Distance, and then bracket and close bracket. And then for the chart title, you have to pick a good title. So we're gonna say the height of,
Maya,
yes,
I'm lost because I'm way behind.
so what are you lost on?
I have the, what do you call that? Which one of the, what do you call it?
You have to highlight the values.
You don't have to like.
Are we all caught up to this point? What else do I have to do right now?
Trend line.
Okay, so this is where I want everyone's attention on the board. You can complete the rest in a second. You're gonna press on one of the points, doesn't matter which one. You're gonna right click, add trend line. Do that. So press on one of the points, right click, add trend line. When you do that, look at me please, look at the board. You have different options that you're gonna pick from. You're gonna pick the polynomial. Polynomial is anything that is exponent 2 and above. So if I pick polynomial, I have to make sure that it's order 2 because I want quadratic, and the quadratic has a degree of 2. If you want cubic, then you do degree 3, which we don't want that. Okay, so we want degree 2 under the polynomial. And you see how now my graph is kind of nice, it's fitting the points. If I do linear, look at this. Is this a nice fit? No, right? If I pick polynomial on the other hand, look at the fit. Dotted line, it's fitting pretty nicely. Now what else do I need to include on my graph? The equation, so I have to tick off the display equation on chart at the bottom, and then I have to also do the r squared. Okay, so you should have an equation which is negative 0.2064 x squared plus 9.4993 x plus 0.7. What does it mean that your r squared is 1? That means it's a perfect fit. Remember, if r squared is closer to 1, okay, it won't be above 1. It will be either 1 or below, okay? The closest to 1 it is, the perfect the fit. So in this case, r squared is actually 1, so that's 100% fit. Make sense? So, do you remember how to snip it?
Yeah. No.
You go to the desktop, you search for the snipping tool. You're gonna say I want a new, so this is your snipping tool right here. You're gonna do new, and then you're gonna make a box around whatever you want to snip. Once you get your snip, you're gonna need that for your assignment. That's why I'm showing you this. Right click, copy, and paste it in your Word document that you're gonna paste. That you're gonna have your assignment in. Okay? So remember that all of this instruction is gonna be in the video. So if you ever like forget how to do things, go back to the video and check it out.
Because I'm using my laptop, I wouldn't have that snip whatever, right?
Sorry?
Did the windows, I think.
How do I cut this?
What was her question?
Snipping tool.
Yeah.
No, she had it.
Oh,
window.
they should have it, right?
Built in Windows.
Yeah, it's built in.
Don't know why the Macs are running Windows. Okay.
Yeah, that's good
How
question.
do you right click with these highlights?
Sorry?
You just save it,
Are we okay with this? Can I just do the next question and I'll give you like about 10-15 minutes to figure things out? Okay? So let's do, because I'm running the video. So determine the maximum of the regression curve. What does it represent? So if you're looking at this graph, right? Where would the maximum is?
20 to 100 and something.
So it's around 23 meters, right? And then it's gonna be around 110, yeah? So this is exactly what you're gonna see. So looking at your graph, right? So if I look right here, if I look at the graph, if I do this, because it looks like right here in the middle, right? And then do this, so it's gonna be around that. So
What
that's
does
right.
regression mean, Maya? What the term
What?
regression?
It's the line of best fit.
Is it line of-
So the regression curve is the dotted line that you have on the curve.
Uh-huh.
That's what we're doing, right? We're finding the regression curve. So it's the curve that best fit. I'll get back to this page, just give me a second.